Hello, welcome to the Yi2 tutorial series, and in this video I want to look at web application caching and how we use it in Yi version 2. As always, I'm going to suggest that if you're looking into caching that you make use of Yi's guide. So if you go to yiframework.com, you'll find the link up in the top right hand corner to the guide, and in the menu at the side there is a section on caching. And if you click on the first document, there's the overview and then links to all 4 of the types of Yi caching. So please start there before you start asking questions on the forums. Make sure you've read all of the stuff in here and you should hopefully find out what it is that you want to know. So if you understand web applications a little bit, you probably know that when a request comes in, a number of things will happen on your web server. It will probably connect to a database, perhaps more than once, perhaps more than one database. It might also do various local file access and even potentially load up the CPU, generating an image or doing some maths or whatever it is that loads up the CPU. But basically, every request has a certain amount of network, disk and CPU demand, and in some specialist applications there might even be other things involved. Now all of those things are what affects the time it takes between the request coming into the web server and the server having generated the response and sending that back to the user who requested it. All of these things add up in time, so the more that you use a database, the slower your page will be. The more disk or CPU you use, all of that will add time to your response. And then what happens if another request is made for that same content? Obviously, in most cases, the exact same thing will happen, and your server will have to handle that disk access, that network, and that CPU overhead required for the request a second time, or a third time, or multiple times. Well, so what? When the first of these resources starts to get near its limit, then obviously something is going to slow down, or you'll cause an error. So if the CPU reaches the limits of your server, if your disk access is so slow that things are starting to time out, or if your database load is so heavy that again you get a timeout error, or even the web server itself might time out waiting for the database to respond. The sooner you get to the point where an error occurs, then the fewer requests or users that your application can support. Now, if you're designing for thousands of users to access your site, you're going to hit a limit at some point, but the more requests you can handle with the same resources, then the fewer servers you need, which is cheaper, and also it might mean that you can use a single database for your application instead of multiple databases, and that's much easier to work with. The easiest way to reduce the use of network, CPU and disk access is to cache the data when it is first generated into memory, and as long as the data doesn't change, any further requests can be served directly from memory with almost no network, disk or CPU required, making the site much faster in most cases. So what is this actually going to cost? Surely you don't get something for nothing. Well, your code is going to be slightly more complex, not too much, but you're going to have to write some additional code. But most importantly, it's going to require additional memory, and that might have an effect on the type of server that you can use for your web server. You might not be able to use the smallest ones that are available, which often have limited memory. But depending on what exactly you're going to be caching, you might not require a lot of memory anyway. So if your site is heavily biased towards database usage, which is indicated on this slide here, we're showing a site where for every request to a particular resource, there are, let's just say, 4.3 milliseconds of database use, just over a second of disk use, and maybe 0.8 of a millisecond of CPU usage, which might not sound like a lot, but if you're handling thousands of concurrent requests, then all of these things can add up very quickly to something that's actually quite unusable. Likewise, your site might be disk heavy. So in this case, it's perhaps reading or writing a large file depending on the request that comes in. And again, in this case, possibly not too much database compared to the disk access. Similar amount of CPU, I guess, for the request. These numbers are not exact. They're just to give you an idea of what your site might look like. And in the case of a CPU heavy site, and again, the same kind of things, probably if the CPU is very high, the other two resources are not being utilized so much. But of course, it's possible if you're, depending on your web application, for you to be using a lot of database and a lot of disk and a lot of CPU. And that's kind of the worst of all worlds, because there's only so much that you can do to actually try and reduce that. In most cases, let's say a normal web application, if we can say normal, is hopefully not too much of any of the three main resources. And what that means is requests don't usually take very long anyway. And so there might or might not be a problem. We might or might not want to address it with caching. So what happens then when we trade off this memory? Well, the good thing really is, if we say this is the same as the slide we've just seen, we've got a site which uses a lot of database. It also uses some disk access and some CPU. But the point of using cache is, once this happens once, then we can take the result of that process, the result of that request, and we can store it in memory. So the second or third or fourth or fifth time that somebody requests the same resource, then this time we don't need to go to the database, we don't need to read from disk, we don't do very much CPU, we quite literally get the object out of memory and we send the object back directly to the user. Now, realistically, that's going to take some CPU, and probably there's going to be some other part of the system that might be accessing the database or the disk. So these are unlikely to go down to zero, although they could do. But as you can see, by trading all of that memory off, by using memory for caching, we get to reduce these really quite significantly. And again, I've only made these numbers up, but I don't think they're inaccurate, because everything that we can remove from here is going to be a time saving. And if your database request, in some cases, could be several seconds, and just with caching, we remove all of that work because we've already done the work once. And similar idea with a CPU heavy application. Again, rather than generating something that takes a lot of CPU, whether that's, let's say, a mathematical site or a site that generates images, anything like that, then we can also likewise reduce the amount of resources that we need by using caching. So this happens once, and then once that's done, assuming that this request is repeatable and we're not generating something different every time, then we can cache those responses and give those cache results back to the user when they next request it. And clearly the same kind of thing is going to happen with a site that's very heavily disk oriented, such as perhaps a photo sharing site. Similar kind of thing. Instead of reading off the disk all the time, especially for often used images, we can cache them in memory. And in some cases, people like Facebook and those kind of people, they put as much memory as they possibly can into their servers, because for the small number of dollars of extra memory, they can save buying additional servers and all of the extra overhead that involves. So let's get rid of that. So before we get going, let's kind of give you an example of what this might actually look like in real life. So I am going to go to a page that I've created. So I'll show you what this code looks like in a minute. I'm going to request this page, and this page is going to take about 4 seconds to load, and it's going to show me a number that I've generated. I haven't really generated it, it's just a fixed number. And if I request a page again, it's going to take another 4 seconds. So let's just show you how I've wired up this page. I've got SiteController. I've added a new action called test, and what this is going to do is going to compute a very slow number, and then it's going to render the view test. And all the test view does is it echoes, at the minute, is it echoes that information. So nothing very tricky at all. Now, in real life, a slow function might be something that does a very large computation on the database. It might be accessing a table with many millions of rows. It might be going across the internet. It could be doing all sorts of different things. But just to imitate what this would look like, I've done something very crude. I've just put in a 4-second sleep call. And so when it calls this function, it's going to wait 4 seconds and it's going to return that number. I mean, in fact, if I returned a pseudo random number, which I probably should do, then you would see whether this is actually called or whether it's not called. In fact, if I look, I think it's called rand, isn't it? Oh, great. Another very amateur deviation. PHP rand generates a random integer between min and max. So let's just pop here and return end a random number between 0 and 10. I don't know, something like that. So let's just go back here to our site. We'll refresh it, and then after about 4 seconds we're going to get some random number 7. If we go again, hopefully in the code you can see that it's calling that function multiple times, and each time, of course, it is going to take 4 seconds. Now we're going to look more at this in a minute, but if I introduce the caching here, then what's going to happen is the first time I call it, the cache is not going to have an item in for this number. So, oh, not that, didn't mean to do that, go back. So it's still going to take 4 seconds, it's going to generate a number. That number's 2. But now what's happened is, because I've now put it into the cache, if I load that page again, it's not going to call the function again because I've cached it. I've cached the value. So that doesn't change because it's not calling the function. Okay, so that's kind of what it looks like, and we're going to go back into the details of the code in a minute. But that's really what we're doing with the caching. We're saying don't do the slow thing every time you come in. If I can still use the old value, then carry on using the old value. And so that's what that looks like. So we're going to now change and have a quick look at how it is that we set up caching. And there are various cache providers that you can use, and they're all listed in the caching thing. If you look under data caching, there's a whole list here of all of the ones that Yi supports. And I don't know the differences between some of them. So you've got things like APC and Memcache and Xcache. They're all separately produced libraries. I'm sure someone somewhere will say that one of them's faster than the others, or maybe it's better in some scenarios than the others, but I'm not going to look at it in that detail, partly because I don't know, and partly because if you care that much about those kind of level of details, then you're probably better off testing some of them and just seeing what the difference is, seeing if one of them is quicker for you than the others. But Yi supports APC, which is a PHP cache. It supports Memcache and Memcached, which are the single server, multiple server versions of Memcache. It supports Redis, which is a distributed database, WinCache, which is an IIS extension for Windows. Xcache is another PHP cache. Data Cache is another PHP cache, as well as some non-memory caches. So there's one that can store cache in a database and one that can store cache in a file. And there's also something called dummy cache. Now, dummy cache is useful because there's kind of two ways in which you can use it. If I go back to this site here, if I quickly go and comment out my cache here, then for some reason Yi doesn't support disabling the cache. So I can't just put disabled equals true. That doesn't work. So what that means is if I don't have any cache configured and I try and run this page, I'm going to get an error. And I'm going to get an error because I've called the cache functions, but they're not wired up to anything, and so it falls over. So if I'm doing developing and I want to be able to write cache code, but I don't for some reason have a cache set up, then I can use the dummy cache. So it's just a pretend one. It doesn't store anything, it doesn't do anything, but it allows you to call the cache functions, but what you'll notice is because it is a dummy cache, if I call this multiple times, every time it's going to behave like the item isn't in the cache, and it's going to generate it again. So that's what the dummy cache is for. The other thing, the reason it's useful is if you do have a cache set up like this, and for some reason you want to disable your cache, again, you can't just comment this out and you can't set it to disabled. So what you could do is you could add one of these in and then comment this one out, and then again you've disabled caching just by adding in a dummy cache. Like I say, I don't know why you can't disable the cache, but you can't. So that's dummy cache. We can now forget about that one. Now Xcache, I'm going to basically look at what Xcache looks like when we set it up. But just a quick note on the database cache and the file cache. In order for it to work really, really well, caching should use physical memory, because RAM is very, very fast and it's actually quite big. So unless your site is caching very, very large objects, even a few gig of memory is more than enough usually to cache things. So memory works really, really well, but there are a couple of places where you can't use memory. One of the obvious ones is if you don't have very much memory, but you still want to enable some sort of caching, then you might want to use the file cache. Obviously, file storage is much, much cheaper than RAM, but it's also quite a lot slower, relatively slower. But that said, it's still possible that whatever it is that you're generating might take, let's say, 5 seconds to generate. So to store that in a file and to cache it into a file is still going to be probably much, much quicker than generating it every time. So a file cache might be an option. And a database cache is useful if you have a web server farm, which we'll talk about later, because it enables you to share the cache between multiple different web servers, something that's not directly possible if you're just storing the data inside the main memory of the machine. So we're going to kind of leave those for now and just concentrate on looking at Xcache. Now, installing Xcache on Linux is pretty straightforward because there are distros, there are packages for the distros. So on Ubuntu or Debian releases, you just do an apt-get install php 5-xcache, and it's all configured, it's going to work and all the rest of it. Although you'll probably still need to edit your php.ini. But on Windows, unfortunately, it's a little bit more of a pain. And what you actually have to do, we might as well, let me just keep this alive, make sure it hasn't logged out. If we type in Xcache and we find the site, so xcache.lighttpd.net, if you go here and it will look at stable releases, you have to kind of dig your way around a little bit. And if you want, say, let's say the version for 5.5 for PHP 5.5, so you click, you want that one, and it will say that you can look in the release directory for Windows, and then you notice a massive long list of lots of different zip files, and all of these are version 3.1.2 of Xcache. These ones have got debug in. You'll notice that they are all different, even though they look the same. So then you've got the PHP version. So you need to find the one that matches your PHP version. Now, in my case, my PHP is installed under Program Files PHP 5.5. So it's very easy for me to see on Windows what version I have. So I'm down to this section. I don't want the debug ones, 5.5. Notice then that 4 of them are not thread safe. Now, these are the ones we want for IIS because IIS doesn't multi-thread the requests. If you use the thread-safe versions, they're going to be slower and you're not going to get any benefit from that. So we're up at these 4 here. And then the next question is, do I want the x64 or the x86? Now, we're talking here about the version of PHP, not the version of your machine. Because mine's in Program Files and not Program Files x86, then that means I've got 64-bit version, and so I want this download, which is 177k, and if I'm interested, the MD5 of the file is in a text file. Kind of think that's fairly pointless because if somebody was trying to hack this site because it's not using HTTPS, then they would hack the MD5 as well. So don't really see there's much point. When you download that file, I might as well show you while I'm here. What you get is you get a directory with loads of random stuff in. The only thing that you actually need is that DLL. So then you copy that DLL, and you can obviously put it anywhere, but it makes sense to put it under your PHP 5.5 extensions. And I pasted mine in PHP Xcache down there. So that's the first bit. That's all we have to do, copy it into there. You obviously then need to tell PHP ini to load this extension. So if we have a little look at what PHP ini looks like, I've put a little heading in there. Don't really need it, but thought it looked nice. The important line is obviously extension equals PHP underscore Xcache. That's the same as loading any of the other extensions. Nothing magic there. But this line is really, really, really important. If you do not add this line in, your Xcache will look like it's installed, but it won't work. You'll get an error, and the error says something very confusing like var. What does it say? I might be able to find it in my PHP errors log. Var is something strange like var cache. Var cache? No. What does it say? Yeah, Xcache var cache was not initialized properly. That's the error you get. Now the problem is, if you look at the instructions on whatever it's called, ppd.net, when you look at the instructions of how to install it, the instructions are not correct, and it tells you, let me just show you in case you don't believe me. Don't know where the instructions are. It tells you to set size, Xcache size, but that's wrong. It is Xcache var underscore size that you need to set. I've set it to 100 meg. I don't actually know what that number should be, but you can find out yourself. Now, the other thing that's important is once you've set that, if you've already been running PHP, you'll need to find it in your process list. It's not here. It's obviously closed down. On Windows, it's called PHP, I think, underscore CGI, something like that. And you need to kill off that process so that PHP reloads php.ini the next time round. And once you've done that setup, so it isn't too bad, but once you've done that, it's always worth just having a quick look at PHP info. So PHP info is a big list of everything that PHP can load, extensions and everything else. Let me just disable that because it might be all right. It might be cached. And then we'll load this. We go back to site test. And obviously, because I've restarted PHP, I've lost the cache again anyway. So you'll see the big long list of PHP info, which is really useful. But all you have to do then is search for Xcache, and you should find this heading. If you haven't installed Xcache, you won't see any of this. It's just not there. You won't find the word Xcache anywhere. But as you can see, there's a load of stuff that's all been loaded automatically, which is great. But like I say, if you get the if you miss out that line, then you will still see all of this. But when you try and use Xcache, you will get the error that I showed you. So PHP info, nice, quick and easy way of working out that everything's working. So let's go back to here and now ditch that and go back to our kind of slow number. So we've now got it installed. If you go back to your web configuration, again, you notice that we configure the cache component. That's underneath components. We set cache. In this case, as I say, I'm using Xcache. If you're using something else, please do, because it works in exactly the same way in code. The only difference will be that line and potentially some other config that you need. But I've set that all up. That works. I don't think I need to go back into there, so I'll close that. That's all fine and set up. I'll close that off. And we're going to talk about the different types of cache, and we're going to go through an example of each one. The first type is just called data caching. So again, if you go back to the guide, you'll see these things here: data caching, fragment, page, and HTTP. And data caching is really the lowest level of caching. It's basically saying I've got an object of some sort and I want to cache it, and I'm going to give it a key in order to cache it. So let's go back to here and let's get rid of that, make it a bit tidier. So this was the slow number demo that I showed you before. And this is basically how you use data caching. There's not really any tricks to it particularly. Ye app cache get, so you're going to call get on your cached object to see whether it's there. If it is there, then it will be returned, in this case into $val. If it's not in the cache, then it will return false. Make sure you use your triple equals, because if you don't, you're going to get all kinds of potential false positives or false negatives. It's not going to work basically. So make sure you use triple equals. Now this would normally be something more useful as an ID than the word test. But because I'm in the action test, this could be anything. It could be, user ID, user data, whatever makes sense, you can use it. But remember, it's usually best to define these as constants somewhere, and then that just means you're not going to misspell it somewhere else. But basically you'll say, is it in there? If it isn't in there, then call my very slow function. And this is the next important bit. Once I've done that, I need to make sure I add it into the cache, because if I don't add it into the cache, then it's not going to be there the next time and it will fail again. And again, all we do, fairly standard ye stuff, ye : app, arrow cache, arrow set, and you give it the key and you give it the object that you want to save. And ye will mostly handle serializing that object. But just be careful if you have a complex or a deep object, just check that it saves and restores correctly. Otherwise, it might not come back in the same form that you saved it as. And then again, in this case, as you've already seen, I render the test view and I'm just passing that out so we can view that number. So that's all kind of fairly straightforward. There are various functions on cache. If we just Control B to go to that. So we've got things like get is fairly obvious, we've already seen that. You can just check whether the item exists without actually returning it, and that obviously returns a Boolean. You can use these M versions as well, and that allows you to get an array of values rather than just a single value. We've seen set, and mset again is the array version of set. Add, so add and set do two different things. What add does is add will put the item in there, but if the cache already contains a key, it doesn't overwrite it. So add is like saying put it in there if it isn't in there already. And there's again a single version and a multiple version of that as well. Delete, as you can imagine, does what it does. And flush gets rid of everything. That's like delete all. Tend to probably not call that very often because it will auto flush stuff when it doesn't need it anymore. And then most of the rest of those are internal methods. So there's not really a lot to cache. And one thing that's important to note is that all of those functions are available on all of your cache providers. So at this level in this code, I don't need to know whether I'm using Xcache or Redis or database or anything else. I just call app cache get, app cache set, whatever. And because of the configuration, that's all just going to work automatically. So that's pretty straightforward, hopefully, data caching. Fragment caching is almost more of a user interface level, but it basically does exactly the same thing. But it does it a little bit more automatically, which makes it easier. So let's go back to our front page. Do you remember this? Not that, this bit here, your recent orders. So we did that in one of the previous videos. And what it does is it says any books that I've bought, show them in a list. Okay, pretty straightforward. Now, in this case, that's not going to be a slow query. It's not going to be a problem. But let's assume that calling that query on the database is really a bit of a pain and it's a bit slow. So we can do something. We can say, well, I kind of want the page to load as normal, but that bit, that fragment, I want to cache. And we can do that in the user interface by going to the index. This is SiteIndex, which is this view here. And if you look here, we have the code to do a fragment cache. So we basically have a function that we call. And again, we have to give it a key, because if we give it the same key as something else, it's going to overwrite the other thing. And then inside these brackets, we do whatever it is we need to do to generate that piece of code, just as normal, nothing different in that part. But then the other important part is we then call this end cache. And again, what that will do, or in kind of shorthand form, is it will do exactly the same as this. If that is already cached, then that will spit out the cached result and return false, and then you're finished. If it isn't in cache, then this will return true, which means then that it will run this code like normal, but then more importantly, at the end of it, it will cache it so that the next time you call it, it's going to work okay. Now, I want to show you that this does actually work. So first of all, I'm just going to comment out that and that and that. So if I go back here now and I check that that works. Okay, so now this is working as before. It's calling into the database every single time. What I've done in the SiteController, let's pop back up to the top. In the index action, I've done a couple of things. Ignore the commented out code here. I've commented out the code that calls the database for this section, and that's just to make it a bit easier to see what's going on for the database. And then if I just show you in the configuration, I've also modified my log, my event log, and all I'm logging is info. And the reason I'm logging info is because in Yi, all of the database stuff is logged out as info. So I'm just going to delete all of that, and I'm going to go back here and I'm going to load this page again. And you'll notice I have 18 lines of database stuff. So let's have a quick squiz. That bit there is basically checking for me because I'm logged in. That's to do with this bit here. It does all this stuff here, which I could probably get rid of. Does all the stuff in the user. And then it says, what books does this user have? So again, that's related to that. And then what else does it does? It then says it gets the books that were in that list, which again is those two books. And then it does some stuff at the bottom, which is to do with the authorization. So it's checking, am I allowed to do this, that, and the other? I can't easily switch that off, so you just have to forgive me that that's in there. So you see there are 18 lines of database stuff. So let's delete that, and if I go back in once more, still 18 lines, all as normal. So let's go back here, and we're now going to put this caching back in. And remember, the first time that we load this page, the cache is still going to have to call the database because it has to populate the cache with information. So I would expect another 18 lines, which I've got. Okay, but now what happens is when I go back in again this time, there are only 10. So you'll notice that it's calling the stuff in the user table and it's calling the access control stuff, but you notice there are no database calls to do with books. So that is 8 statements that now don't need to be called on the database, but I'm still getting my output, I'm still getting my fragment, and in actual fact I can keep calling this as often as I like, and that's going to keep coming back. And every time it's just going to add another 10 lines in here, all to do with users, nothing to do with books, which is fantastic. So that proves that this is working okay. But it does then beg a very simple question. What happens if I want to call the database again? Because clearly at some point this list is going to change. So how often do I change it, or how do I change it? Well, Yi provides 2 mechanisms to do that, and in fact most caching systems provide 2 means to do that. The first of these is just simply a duration, and the duration can be passed to most of these functions here. So in properties, let me just check how we do it in the fragment cache, or even in, if I show you quickly in here, when we actually set it here, we provide the name and the value, and by default that will stay in the cache forever until it is either deleted manually, or the whole thing's deleted, or the process restarts and all the memory is lost. But one of the things that you can pass in here is a number of seconds, for instance, that you want that to be cached for. Sorry, chewing my words here. And that's in seconds, so I can provide 60 seconds of duration, and I can manually specify that, which is fine. There is a way to do it with the fragment caching, because I did see it. Caching options, duration. Okay, it's done as an option. So you can see there that if we do that in our index, and we pass that in here, and again it will be in seconds, 30 seconds, whatever. And it's important to note that depending on how many times you're calling this page, even a short duration of perhaps 10 seconds might still make a massive difference to your site. Because you think about somebody who's going, oh yeah, here, and then I'm kind of going back to home, and then I'm contacting someone, and I'm going back to home again, and keep going, I'm going to go home. So even within a short time, they can be calling this lots and lots of times. And so even a short duration might mean that only one of those recent page clicks has actually called the database and none of the others have. So even with a short duration, that can work quite well. Obviously the ideal is that we can make this much, much longer, but the longer we make it, then the more chance that this is going to be changed, but the user isn't going to see the change because it keeps pulling it out of cache. And so the other mechanism, which we're going to look at later, is called dependencies. And dependency is a way of writing some code that will allow you to force the cache to be invalidated, and so therefore the page loads everything from the database again. So that's the duration. You can specify that in any of those. The third part of caching in Yi is called page caching. You'll be able to guess what page caching is. It means we're going to cache the whole page. And this is done in a slightly different way. This is done as a behavior. So at the minute it's commented out, but let's uncomment this for a second. So we're going to go and we're going to cache the index page. Now if I got rid of this like that, it would apply to all of the actions in the controller, but no need to do that. Let's just put it on index for whatever reason. And what I've done here is I've provided a duration explicitly. I've said let's go with 10 seconds. And another thing that's really useful is you can say, well, I know you're going to cache the page, but if this value is different when the user requests the page, then you can't use the cache. You need to generate the page again. So in other words, it's a bit like the vary header in HTTP. If this is different, then what needs to be returned to the user will also be different. So you must generate it. So that's a good example, because language is obviously something that says even if nothing else has changed in the content on the page, if the language is different, it's still going to be a different response, and I can't use the cache. So let's look at that initially. We're going to use our log again. And again, the first time we turn page login on and we go here, it's going to have to request everything from the database, so that's fine. We kind of expect that. Now what happens if I click it again? Nothing. Click it again, nothing. Okay, so it's actually cached the entire page. All of the HTML that comes out of that has been cached in memory. But in this case, just to demonstrate, I've also said that only lasts for 10 seconds. So now if I go back and I request it again, it's going to call the database again because the 10 seconds expired. So that page gets marked as dirty. It will get deleted, or the entry in the cache will be deleted, and it'll be generated again. But notice that we're still using this cache. So when we went back in, there's still only 10 entries and not 18. So you can have multiple layers of cache. I could even have at the end. I could even have some data caching in the very same page, and they all work independently, even though they work in the same kind of way. Because they're all going to have a different key, then they all work independently. So page caching is pretty cool. But like I said before, the real question is, how can I invalidate this page when something happens? Because maybe nothing's going to happen for a month or 3 months or 6 months, but at some point something might happen and I want the page to be invalidated. So I don't really want a duration of 10 seconds when maybe this could be, 10,000 or even unlimited. I want a really, really long duration. I mean, what's if I ask Google what 6 months in seconds? Oh, that's a lot, isn't it? 6 months is 1.555 or whatever it is. Anyway, I was trying to be clever, but with 7 zeros, so it'll be I think. So let's say that's the duration. I want a 6 months duration. Let's just say this front page does hardly ever changes, but sometimes it does. So what can we do here? And this is where I want to try and use my database if I can. So what I'm going to do is I'm going to add in a dependency. Now, a dependency is the ye mechanism that determines when a cache item can be invalidated. So if the duration is long enough, then the item stays valid, but if this returns a different value anytime it's queried in the cache, then the cache will assume that the item needs to be changed and it will regenerate. And there are different types of dependencies. There are, what have we got? A file dependency, which looks at the file modification time. And again, that might be useful if you're caching anything related to some kind of file. And it also has a database type, which we're going to just look at here, an expression dependency and a tag dependency, which will show you those as well. And the last one is a chained dependency, and a chained dependency just allows you to have multiple dependencies inside a single container so that you can set that onto your cache and it will check for all of the dependencies to be true. So the file dependency, like I say, purely checks for the modification date, and what's important is that you're not looking for true or false, but when you insert this item into the cache, it will call, in this case, this piece of SQL and store the value it gets back, whatever that value is, string, number, anything else, it will store that value. And every time you request the item from the cache, it will call that again. And as soon as that value changes from what it stored to the first time it was set, then again it's going to return false. Your page is going to regenerate, your object is going to regenerate, and it will do the same thing again. So what I've done is I've said, well, let's use the count of the number of books. Now, that's not a perfect description of the validity of this page, but let's just say it's close enough. So now, if you look, very, very quick when I load it. Let's just go into here. I'm just going to make sure that's definitely working. Go back here, count star from book. So what's interesting is the only SQL that's being called is the SQL from this dependency. Now, why is that important? That's important because it shows that every time I request this page, it's going to have to call that to work out whether my page needs to be changed. Now, what's interesting is I don't know whether it's calling the same thing twice or whether that's just a piece of information, but hopefully it isn't. But if I keep clicking that, and with the duration that I've set, again, nothing else is going to happen here. It's not going to call anything else. It's just going to return the item from cache. And of course, the idea is that what you call here is going to be much, much quicker than generating the whole page and calling whatever else you want to call. So that's pretty cool. Cool. So I'm now going to go into the database here, and I'm going to insert a new book. So the ID is going to be automatic. So let's put in, I don't know, Little Women or something. Description, I don't know nothing about this book. Let's let's be correct. Little Women is a novel by blah 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 blah. That'll do for my description. Control V. Now I haven't set her up as an author, so for now I'm just going to say that the author is whoever. Don't really care. ISBN number doesn't really matter. I think that's doesn't need to be filled in, and let's just give that a rank for want of a better idea. Right, press go. So that's inserted. If I go back to browse again, I've now got 6 books instead of 5. So of course what we're going to expect is, let's just go here, make sure that's still empty, is when I now request a page again, where's my SiteController? I'm going to expect that it's going to call that. It's now going to go, there's 6, not 5. And so it's going to make the cache stale, and it's going to re-request the whole page minus the little bit that we've got inside the cache, and then it won't do that anymore. So I'm going to do that. Go back to here. Oh, boff, look at that. Select count from book. It's gone, oh, hang on a second. Yep, it's all changed. So I can call all the user stuff. Going to do a bit of book stuff just to fill in that middle bit. Blah, 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 blah. Select stuff and blah, 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 all the rest of it. And then that's it. We're kind of done it all again. And now, again, if I do this, hopefully it's just going to be calling select star from book again. So page caching, very, very easy. And as you can see there, even the dependency stuff is really straightforward. So let's just look at some other kinds of things. An expression dependency really just allows you to have a bit of flexibility. Oh, I've done something naughty with my quotes. It allows you to provide any kind of PHP callable, and that's going to be passed to the eval function. I'm sure you've all heard of that horrible function that just basically calls the code manually. Evaluate a string as PHP code. Yeah, it's very dangerous, blah blah blah. So it's up to you to be careful about what you write in there, but in this case I've said, for instance, get the month number of the current date and use that as your key. So this is kind of like an automatic caching thing that's going to say, well, the first time this page is cached, let's say at the minute it's October, which is 10. So it's going to call that, the number's going to come back 10, and 10 is going to be stored against that cache entry. And assuming that nothing else happens and it's not deleted or whatever, then the same page is going to be returned until November comes along. That returns 11 and the cache gets invalidated. So this would be a very crude way of getting a monthly cache time. Alternatively, of course, you could set a duration equal to 1 month worth of seconds, but it kind of depends whether you want it stuck to the actual month rather than to a month of seconds away from when it's first accessed. So it's slightly different. And whatever you put in there, like I say, gets passed to eval. And again, it's the value that's returned that's important. So it doesn't return true or false. It just returns a value, and that value is stored. So the last dependency I want to look at, because it was a bit confusing when I first looked at it, was the idea of a tag dependency. Now, a tag dependency really is just a way of grouping different cache objects together. So let's say we've got our index. Let's go back to here. We've got our index, and the things that are relevant to this front page are my books and me. So users and books. They're the kind of things I'm interested in. Nothing else here is automatically generated. So they're the only kind of objects, the only database data that relate to this page. So I'm going to create a dependency, and I'm going to give it a tag dependency, and I'm going to give it some tag names. I'm going to use books, and I'm going to use users. I mean, I could, if I wanted to, match the name of the model, but it doesn't really matter. You can make these anything. If you're only setting one tag, you can use a string instead of an array, but whatever. Books and users is how I'm going to tag this page. So let's just, actually I should probably have to get this to work. So let me just check first that that's still all working. It's fine. Still, why is it still? shouldn't be selecting star from book, I don't think. That's interesting. Count star from book. Oh, I think it's because the cache is still valid from the previous time. So let's just go and kill off PHP and process tree. Yeah, you got to be a little bit careful with caching because you've obviously got a lot of stuff that can go wrong. Right. So if I go now, right. So this is basically completely cached. Yep, nothing else happening. No more database calls. Now, if I go back to my code again and have a look, what I'm saying here is there's no real kind of obvious dependency like a database or whatever. The dependency is just a tag name, and that name can be anything. Well, why is that important? Well, let's just go to books a second and come back to here and have a look. Okay, apart from the fact that I went to books, and so it's going to do all of that kind of stuff. It hasn't actually, this is still cached, and it's still not doing anything. I'm not sure why can't it find books anyway? Obviously broken something somewhere, who knows. But what I can do, the way that this dependency works, this tag dependency, is let's say I'm in the BookController. Every time I change a book, so index doesn't change it, that's fine, I'll leave that alone. When I create one, that's going to change stuff. So I call tag dependency invalidate, and I pass it in the cache that I'm using, which is just a normal one because you could have more than one, and I'm going to give it the tag that I want to invalidate. And likewise, if I update a book, that might be the title changing. I'm going to invalidate it. If I delete one, then I'm going to invalidate it, blah, blah, blah. So all of those things are going to make my page invalidate. So let me try and do this in a way. Right, so let's just go to books. Oh, that's a routing thing. I think that's probably because I've been playing with the URL manager somewhere. Yep. Books, there we go. Let's go again. Books. Enable strict person pretty URL. Oh, I don't know. Let's oh no, it needs to be in books. Sorry about that. Let me just fix my menu. Views, layouts, main. So where we do books, we've got book index. That's fine. That's funnies, but when it goes there, books, authors, books. Again, should have tried all of this. Action index, query, active data provider, query book find. What have I done? Let's get rid of that. Oh, that's really annoying, isn't it? Right, let's just go back to here anyway. Hopefully still cached. Okay, now what I'll do is if I go to actually it's a BookController, isn't it? So that should actually, oh, is it because not that. Well, let's just try anyway. Edit 2. Let's have a look what books we got. This is a bit annoying, isn't it? Books edit 2. Why is this not working? Why is it not working? What happens if I get a link from one of these other ones? Edit. Oh, author update question mark. So book edit question mark ID equals 2. Oh, for goodness sake. So what happens when you keep changing lots of config all the time and not really paying attention to what's going on. So book, I don't know, let's bring all these back in. I don't know how I've managed to break the book controllers. I'm pretty sure it was working the other day. But let's just go here. I don't know, what about this? Is it going to work now? No, no. Anyway, what will happen is, when I do a book, it will, yeah, there's no point wasting your time. When I call invalidate against either one of these tags, then this page will be invalidated, and again it will get deleted, and next time it comes back to here it will load the page again. So that's what a tag dependency is. It just gives you a way of logically grouping things together. Quite useful in page caching, but quite useful in lots of places. Anywhere where you know that something's related to users, you could just add it in with that as a tag dependency. And you can pass these dependencies in code as well. So where's our thing in set? So as well as, if we just go back to here, and the duration, so if we go back to here, I think it's the fourth parameter is a dependency. So again, you could just do all the new, tag dependency, whatever, and you could do all the stuff there, pass in all your configuration and stuff. So you can pass that in a function as well as in config. And that's pretty much all of the code that we need to look at. So one of the things I mentioned before was about what happens in a web server farm. So caching is primarily memory based, because obviously memory is very, very fast. But if you're running in a web server farm, unless you can guarantee that a user is always sent to the same web server, something sometimes called sticky sessions, then the caching on one server will not be propagated to all of the other servers, since every time a new server gets met, another object will need to be generated again and cached in the local server's memory. So the easiest way around that is to use a database or a Redis cache, which are both database providers, and that database can then be shared between web servers. They're also slower than memory-based caching, and if the problem is your database access, then adding a database cache might not be the best idea, although it might still work, because if you use a separate database for caching, then you might still be able to reduce the amount of load on your main database. So again, it's always worth testing these things. And also, if the issue is to do with very, very heavy CPU usage or disk access, then again, the shared database access might be the best way of getting your cache and sharing it across the web server farm. The other option is you can set up shared servers that use memory, but then you would have to do that manually. Yee's not going to do that for you, and then those systems then have to make sure that the memory of each instance is updated every time the memory in one of the other units is updated as well. If you only have one shared server, then it becomes a single point of failure, and that might or might not be acceptable for your web application. And the other thing, just to finish with, is to remember that caching is not necessarily an all or nothing situation. So if you manage to cache 50% of the requests that come to your site, even if that's not all of them, that still might be a very good improvement over having no caching at all. Even if every now and then a person gets sent to a different web server with the same request, maybe you can live with that. One of the best pieces of advice about optimization is don't do it until you've tested it, you've seen what's actually a problem, because the other issue is that sometimes what you think is a problem isn't necessarily a problem. So test it, see what's going on, measure your performance, find out which pages are slow. If you can stress test your application to find out, then that's very useful. But otherwise, using cache itself is very, very straightforward, and Yee provides you with many tools to make that easier. So again, any comments or questions, please put them below. Otherwise, I'll see you in the next video.